Right, so this one, let's give myself some more real estate. So join the room. Start machine. Right, so CVE-2021-4034, colloquially dubbed Pwnkit, is a terrifying local privilege escalation located in the Polkit package installed by default on almost every major distribution of Linux operating system, as well as many other NIX operating systems. In other words, it affects virtually every mainstream Linux system on the planet. This room will provide an overview of the vulnerability as well as recommendations to patch affected systems. A vulnerable machine has also been attached to allow you to try the vulnerability for yourself. Without further ado, let's begin. So, CVE 2021-4034, aka Pwnkit, was discovered by researchers at Qualys, again, and announced in January 2022. The technical security advisory for this vulnerability can be found here. The vulnerability has existed in every version of the policy toolkit since it was first released in 2009. So, like nearly 11 years this thing went, or 12, even longer than that, isn't it? It's like 13 years this was active. Allows any unprivileged attacker to easily obtain full administrative access over any Linux machine with Polkit installed. Unfortunately, Polkit... Oh, we already read that. Right, that was the same as above. The ease of exploitation and ubiquitous nature of Polkit makes it an absolutely devastating vulnerability. However, fortunately, it's not exploitable remotely, making Pwnkit purely a local privilege escalation. Before we look at the vuln, this is the same stuff as before, so I'm going to skip that. So, as mentioned previously, Pwnkit vulnerability exists in the pkexec utility, primarily the primary front end of the Polkit system. We won't go into too much detail here in the interest of readability. However, you are encouraged to read through the Qualys security advisory for a full technical explanation of the vulnerability. Of course, it's a nice text doc. So in the short version of this is that versions of pkexec released prior to the patch don't handle command line arguments safely, which leads to an out-of-bounds write vulnerability, allowing an attacker to manipulate the environment with which pkexec is run. This is all you really need to know. But for the slightly more technical explanation, read on. More specifically, pkexec attempts to pass any command line arguments that we pass it using a for loop, starting with an index of 1 to offset the name of the program and obtain the first real argument. If we entered pkexec bash and then pkexec as the name of the program, it would be argument 0. The actual command line arguments start at index 1, the name of the program is irrelevant to the argument passing, so the indexing is simply offset to ignore it. What happens when we don't provide any arguments? The index is set permanently to 1. The following pseudocode may help you visualize this. So n starts at 1, while n, or for n, is less than the number of arguments, then increment. If the number of arguments is 0, then n is never less than the number of arguments. As such, n stays equal to 1. And the loop is bypassed completely. I don't quite get that. So n, if that's a 0, then arguments... Oh no, sorry, yeah. Arguments has to be... Okay, it's the other way around. I'm talking my ass. So if that's 1, it will never be lower than 1. No worries, dude. Thank you for checking in. So yeah, okay, so that makes more sense. So it completely doesn't do anything in the loop because it doesn't meet this criteria. So this becomes a problem later when pkexec attempts to write to the value of the arguments in the next at the index n. As there is no command line arguments, there is no argument at index n. Instead, the program overwrites the next thing in memory, which just so happens to be the first value in the list of environment variables.
Says.
Bye. So when the program is called using C function called exec CVE, in other words, by passing exec a null list of arguments, we can force it to overwrite an environment variable instead. For context, certain dangerous environment variables are removed by the operating system when you attempt to run a command that has the SUID bit set, as psexec does by necessity. This is to prevent attackers from being able to hijack the program as it runs with administrative permissions. Using the out-of-bounds write, they're able to reintroduce our choice of these dangerous environment variables by tricking pxexec into adding it for us. There are a variety of different ways to abuse this, all leading to code execution as a root user. Is Pwnkit remotely exploitable? Nay. In which Polkit utility does Pwnkit vulnerability reside? pkexec, exactly the same as the other one. So exploiting Pwnkit is lamentably incredibly easy. There are many disparate exploits available online. Writing your own version is not particularly difficult. The version we'll be using is written by C by Arthurepsy and was released soon after the Qualys security advisory was made public. The repository can be found here. The variation of the exploit makes use of the dangerous GC or gconv path variable to include malicious shared object file that calls the bin shell with root permission. Let's just quickly set up a folder for this. This is Pwnkit. And that's GCC, what's it called? CVE. Alright, so I've built that. So first we must connect to the target machine in, let's do that, so SSH tryhackme 157.20. So we're in Pwnkit, and once connected we need to, so cd Pwnkit gcc output exploit. We can then run the exploit to get root. Sweet. So read through the file and try to understand how it works. See if you can match this up with the Qualys security advisory. So the beginning of pxexec's main function processes the command line arguments 1, 3, 4. So this is that if statement. So in code, let's go Sublime. So it just overwrites it with that. Trying to see where it does the psexec bit. pkexec, not ps. Or is it actually using that? Okay, there we go. So it runs exec with no values, and it's already overwritten the path and stuff at this point. Cool. So what is the flag located at? Root flag txt. Congratulations, you exploited Pwnkit. Using the Qualys advisory and the repository linked in the task, write your own version of the Pwnkit exploit. I am not going to do that. I need to know a lot more C before I'm comfortable with that. So now we've seen the devastating impact of CVE 2021 and 4034. How can we protect against it? Fortunately, developers tend to be fairly fast when it comes to developing patches for critical vulns. As a prime example, at the time of writing, Canonical have already released patch version of Polkit in the apt package manager for all versions of Ubuntu which are not end of life. Patch version can be installed with a simple apt upgrade. In distributions which have not yet released package versions, the recommended hotfix is simply remove the SUID bit from the pkexec binary. This can be done with a command such as the following. This is far from ideal, however, as it works as a temporary solution until more distributions start packaging versions of Polkit that are patched against Pwnkit. It should be noted that there are many variations of Pwnkit exploit using different environment variables and exploiting the vulnerability in different ways. Some of these leave traces and logs behind, others do not. You can check to ensure the system is patched by attempting to run a copy of the exploit against it. If the exploit returns the psexec help menu, then the system is patched. Patch the vulnerability. I mean, it's already patched, it wasn't vulnerable in the first place. Congratulations if you have reached the end of Pwnkit room. During the course of the room, you've been given a high-level overview of CVE-2021-4034, some of the available remediations to patch it, and you've also been able to use one version of the exploit to attack and compromise a vulnerable target for yourself. You should now have working knowledge of the devastating vulnerability. However, fortunately, Pwnkit wasn't the first Polkit vulnerability in this time period. You may want to try Hack Me Room CVE-2021-4034, which is the one we did a second ago. Timing attack that led to another privilege escalation. Sweet! Running out of info rooms now. Let's